Hi, can you hear me? Okay. Hi, I'm Bertrand Carlier. I'm going to talk about a lot of topics that Prabhat already talked about, but with a different approach, maybe different words, but a lot of concepts he evoked. I'm going to talk about that. So, a brief word about myself. I'm working for Wavestone, which is a consulting company present on 4 continents, and we have cybersecurity practice, which is 400 persons, and digital identity, which is the practice I run, is more than 120 persons. I've been doing identity. I've fallen into identity something like 15 years ago, and I've been looking at standards almost from the start, and I'm very enthusiastic, and I really like standards being used when they can, and they can for a lot of use cases, they can provide you with answers. I'm going to talk about microservices, and first I'm going to say what I mean personally by microservices, which is another thing. Microservices are things that are called by the software clients. That can be anything from a mobile application, a JavaScript running in the user agents, or a server-to-server interaction. So we're going to call one API, which is going to call another one, and then another one, and then lots of other APIs are going to be called, and you're going to have an API chain, an API tree to call. You're going to end up with front APIs, backend APIs, and I'm going to try to focus on the backend APIs here and how you're going to secure those. And this will generally involve also various degrees of automation around continuous integration and continuous deployment tools that you may have, and this will come in handy at some point to provide security on those APIs. So let's start. This is how to secure microservices. Easy, right? You just put an API gateway, a firewall, you do network isolation, and you put an OAuth2 server. You get tokens, and that's it, right? Well, it's not that simple, of course. If you go down that path, you will face a lot of trouble, and you will have a lot of questions unanswered. And I propose that we go the right way and the more complex one. Because what happens is inside, should the front token that your client got be propagated into that network bubble, or could the API gateway swap the token with something? That's something that Prabhat suggested, and it can actually work in many cases. And do I need to take care about which API can call which other API? Is there some security issue here? Of course there is. Option 1, clear text header. So I have a front token that I just swap for some headers, HTTP headers, and I just provide my APIs with user ID, client ID, maybe user access rights, and everything's fine. Developers don't have to worry about security. They just get the information into the request, and that's it. Of course, that's not really secure. Any compromised API can call any reachable API and impersonate, augment the user authorization when they want. So that's not something you want to do. That's something we see. Token transmission. So let's just take that front token and pass it to the other APIs within that network bubble. So that really allows to ensure you have some user integrity and rights integrity. You cannot impersonate anymore the user. You have to have a valid token before, but you're going to ask your API developers to validate that token. So you're going to have them do some security stuff, some crypto stuff, or you will ask them to go do a round trip through the API gateway, so this can be done at the API gateway level. It's still not the safest because you can actually do bad things with that. You can have an API call any other network reachable API, and that may not be supposed to be done. You may have ERP API, calling an HR API and getting sensitive information, for instance. That's not something you want. Option 3, auth scopes. So you're going to ask to request a token against the API, against the authorization server with a certain scope to call certain APIs. And if you want to reach other APIs, you're going to request another token with different scopes. And maybe some clients are allowed for the purple scopes, the purple token, and other clients are only allowed to request green tokens. So that way you can have some segregation between which API are going to be compromised when one API is actually compromised. And you can mix that with the approach where the gateway is going to swap the token, and you're going to get a new token, let's say an orange one, that is going to be able to call some other APIs. So you can have a mix here in the way you want to do that. It's still not perfect. You still have some questions when you want to move from one scope to another. How are you going to do that? This often requires your design people to define business domains for the APIs so that any chain is self-sustainable. But in many cases, in many contexts, this is secure enough actually. Propagating a token and making sure scopes are enforced and well managed, that can be secure enough. So keep in mind, this is something important. And when you move from that, you may be in some very risk-averse context, and you may need you may have a regulation that enforces you, that mandates you to do fine-grained authorization between APIs, fine-grained user rights enforcement. So you're going to move to some options like token exchange. Token exchange requires that any API, before calling another one, needs to get a new token. It needs to exchange the input token with the output token with new scopes, for instance. And that token is going to contain the user identity from the start and the identity of all the APIs that you went through. That can be interesting if you want to check whether it's a legitimate call or if it's a rogue call from a compromised API. That's how you may detect that kind of thing. But of course, it's not perfect. It's like Prabhat said, it will introduce network latency to get each token, and this can be a real burden to developers if they need to negotiate a token before doing any API calls. If they cannot reuse the first one, that's a burden, and you need to help them. You need to provide them with some helper libraries and to have a product for them to do that stuff instead of them having to code that themselves. And there are many other options. The idea here is to work on service-to-service authentication and authorization, and Prabhat provided some good examples of how to do mutual TLS connection at the network level, or how maybe you can use client credential tokens in addition to user tokens, or you can use self-issued JOTs like Prabhat mentioned. And I encourage you to have a look at Bertrand's work with nested self-issued JOTs. It actually permits to do something like token exchange, so you will have a traceability of all the API chain, and you don't need an authorization server to do that. So you don't need the round trips to the authorization server, so you get a lot of improvement when you speak about network latency. Token validation, you can have the approach that I presented in the options first with the API gateway, which is basically a reverse proxy that is going to do some check on the request. You can have embedded software libraries that you get to deploy within the microservices. That's like an agent, and it is tied to the technology you use to develop your APIs. Or you can have a micro gateway approach, a bit like Prabhat said, but maybe not the exact sidecar pattern that he was talking about. And then you always have that question about by value JOTs or by reference tokens. That's something very hard there's no definitive solution. Of course, you're going to lose revocation if you use by-value JOTs, but you're going to have latency if you use by reference. So that's a very tough call to make. From my point of view, the main difficulties are not technical. They're more about how you're going to do the key management to authenticate or to sign tokens at the microservice level. Microservices are going to be popped in. You're going to scale out and to have multiple instances of your microservices. How are you going to provide them with, securely provide them with a private key? Is it going to generate it when you spawn the microservices? Are you going to give it to it? That's something very, very tough to tackle, and I encourage you to not forget to look at that. Same thing with public keys. Are you going to publish that? How are you going to publish public keys so that APIs can get identities of the previous APIs in the chain? And the other topic that is really difficult from my point of view is, well, if you're mature enough in your API security and microservices security, you're going to aim for a fine-grained access policy, and you're going to try to centralize that and to define, to maintain those policies. And this is really hard. And I think the pattern that Prabhat provided a few minutes ago is a very nice one with a message broker that can send policies to local decentralized PDPs. I think that's something very interesting to have a look at. So maybe you didn't see yet, but I'm from France, and I can prove it because I can talk like that if I want. I love cheese, of course, wine, and bread to eat my cheese. So we're going to have a look at some clients from France over that topic. So let me tell you about a cheese retail company. Imagine we have a cheese supermarket all over France and a few other countries, and they have APIs. They went the API way a long time ago. They had APIs for the mobile device, the mobile application, for the in-store salespeople, so they can have a real-time inventory, so they can provide the customers in the stores with information in real time. The same APIs are used actually by the website and the customer website and the customer mobile application. So this is one set of API that is not so critical in terms of security. I mean, the price list is public anyway. But you also have APIs for more critical information like HR or ERP information. So this is how it looks internally. You have an API gateway. It is a three-level architecture. The API gateway just checks the token is valid. It is not expired. It has been issued by someone I know. So I'm going to let the request go through, and I'm going to serialize the token and pass clear text information to the fences. Fences are dedicated services that you must go through before reaching the real APIs. Those fences are going to check user access rights, and all the network isolation is done by the pass that we work on, a cloud-based pass. And if you need to go from one business domain to another, you have to go through the fence again. And lastly, the microservices are going to check the client access rights. I mean, the software client access rights. They're not going to check the user access rights. This has been done at the fence level, so I'm going to trust the fence that it did its job correctly. And microservices are just checking that the application is legitimate to access the information or to do any operation. Now that we have cheese, we need some bread. And we have a very large company doing trading business in the bread and viennoiserie business. They went through a classic story of digital transformation. They wanted to have new varieties of products, bread and croissant, before competitors. They wanted to beat them on the market. And they want the agility to develop new products and means to trade them. they went API in some API first motto. So that means first I build my APIs, and then myself, the company itself and its clients can leverage the same APIs to build on top of that the applications, mobiles or web applications. So APIs are the core of this company, and they are under strong regulation. I mean, we do not, we take very seriously health issue in France, so pain au chocolat or sandwiches needs to be perfect. Also, we have to protect recipes. I mean, only French guys know how to do croissant. That's why you don't have a good croissant here. because we protect correctly the recipes that are behind those APIs. So they went the token exchange way. So with one token, you can call front APIs, and then if you need to go to backend APIs, you need to exchange your front token with the back token, and then you can access other APIs. What's interesting here, so it's the classic token exchange pattern, and each API has its own scopes. So a token valid for one API cannot go to another API, that's for sure. And what's interesting is that when we look at how developers actually leverage what we provided them, we provided them the possibility to do fine-grained authorization for both client and user at every API. Actually, they don't check user rights in the backend APIs. They trust front APIs to do user checks, to do fine-grained user permissions enforcement, and they only check application rights, client rights. The more you go into the backend, the more this tendency is real. And so we provided them with more than they needed, and that was some work that today is not leveraged. So maybe there's a balance here to find on what you provide to your developers. Lastly, we need to talk about wine, of course. Wine as a service, isn't that great? You pay as you drink. You can have your next bill estimation at the end of the month based on your current consumption. You know how much you're going to pay at the end of the month. That's terrific. You have wine advisors, AI-powered and machine learning, etc. It's a fantastic environment. Come to France to work on that. That's and of course, you need to have data sharing and integration with partners. You have social networks where you can get badges, etc. That's very important. You cannot miss that. And they had a very classic approach with an API gateway and token propagation to the API, so very classic one. They just had a scope management, so they did what is secure enough at some point, and they were not strongly regulated, so they needed traceability, but basic traceability. They didn't need to do fine-grained policy enforcement at every level. But we work with them to leverage their continuous integration and continuous deployment tools. And we came up with this pattern, which is kind of a micro gateway pattern. APIs can be developed in any technology, and they just have to fit within a container that we provide to developers. And these containers contains some open source software based on Apache and a module, ModAuth OpenIDC, which is a great module. And containers, when it spawns, this Apache acts as a reverse proxy just before the API and can enforce any policy that is configured into that. So we have centralized policy in a repository that are deployed real time when we spawn a new microservice. The repository is checked out and the policy is deployed as configuration on our container, and that container is immutable, and that really works well. And I think with Prabhat's idea of message broking to update policies real time, it can also be improved. Thanks for that, Prabhat. So as you can see, these are three very different environments where we came up with three very different solutions. And because the premises, the assumptions at the beginning are different, we wanted to maximize development agility for developers, and we wanted to have independence between feature teams in the first case, and we came up with business domain segregation and coarse-grained scopes and fine-grained user rights enforcement. In a very strongly regulated environment, very risk-averse, we came with the token exchange pattern, and that's what we used, and actually we don't use it to its full extent. And lastly, in another environment which had heterogeneous API technologies and historically some unsegmented network, we came up with this. We're actually moving to a macro gateway approach to be better at how we deal with API security. And we are really leveraging the CI/CD tools that they are deploying right as we speak. So a few rules to balance API security when you design it. Different contexts will result in different architectures because everyone does not have the same security requirements, stronger or not. You have some capabilities around the automation of build and deployment of your software, and you may leverage that, or you may not leverage that if you don't have any. And there's the debate, of course, always. It's a 15 years debate about whether you use a reverse proxy approach or an agent approach, or now you have the options to do a macro gateway approach. So that's one more question for your security architects to tackle. The second message is most security requirements are going to fit within the tokens transmission and scope management pattern. Unless you run a nuclear plant or a very risk-averse company, strongly regulated, like a bank, for example, you don't need very fine-grained service-to-service authentication. You don't need token exchange or nested self-issued JOTs. If you think you do need that, I encourage you to change that assumption. And if someone really insists, maybe you have to. So there are many available blocks to do that. Many of them are standards. Many of the concepts I talked about are available, and the main difficulty is to know how to arrange these different blocks together to actually build something that in the end is actually secure. That's the message I want to emphasize. And we have a saying in France, and that's a French superhero that's going to say it, is do or try it. Thank you. Any specific questions I can answer? Yeah. Yeah, go.
Because you had on the slide centralizing and centrally managing the fine-grained authorization as one of the remaining challenges. Can you elaborate more what those challenges exactly were or are at least for these customers?
Okay. Well, there's the technical difficulty, but several products or several approaches can actually do that, and you can combine blocks to actually achieve that. The idea is that you have to find some place to centralize that some people are going to access and update regularly, and you're going to ask very different people to do that, very different people from different businesses within the company with different security backgrounds, and you're going to have to provide them with a single language, single grammar to express those policies. You're going to have to actually write this policy and make sure this evaluates correctly from the business ID of the policy to the technical implementation. I think it's very difficult to do this.
So it's a people problem more than a technology problem.
Yes, I think that's more an organization and people problem.
You said that you must keep track of all the identities request, all the component identities the request came through. Is keeping a trace of all the authorization requests that were checked for one request is a way to answer this requirement? Or do you see that?
It depends. Yeah, I think it depends actually on your need. Is your need to trace this and to have a log that says it went through this, and I can prove it? Or is that call chain something that you want to evaluate at runtime to do some decision within the API? If the call is coming from here, that's the response. If the call is coming from another pass, that's another response that I want to send. Those are two valid business requests, and then the way to do that is different. It might be different, or you can come up with a single technical approach that solves both questions, I would say. Yeah?
Same question as the gentleman, but relating to key management, what are some challenges and solutions out there?
For me, the challenge is to find within the enterprise some existing components to reuse as the key management system, and that is going to distribute keys. If something exists, like a PKI, the company is going to try to reuse that, and that may be difficult because it may not be adapted to the microservices approach. I think that's one part of the answer. The other part is actually how are you going to spawn a new microservice, and how is it going to get a new identity securely? I mean, is that a legitimate microservices that just spawn or not? How are you going to achieve that? And that's where I don't think we have really secure solutions there. Any more questions? No? Thanks. Thanks, everyone.